L2 dL2 dx is equal to, now here's where it gets a little tricky. Derivative of b squared is gone, that's fine. But here I get 2d minus x, but the chain rule compels me to keep going. And what do I get for, in addition, what's the derivative of this with respect to x?
Minus 1.
Minus 1. Right? Because you have to take the derivative of d minus x, and the derivative of minus x is minus 1. Okay. So that tells me that dL2 dx is equal to, the 2 cancels, and the L2 comes to the other side, right? And I'm going to get minus d minus x over L2. Right? The minus sign, the d minus x, and the L2 comes to the other side, getting the dL2 dx. What's that? All right. So now I come back to this part and I say I have n1 over c times x over L1 minus n2 over c d minus x over L2. Yes? What? Back me up. All right. So do you see where I got this then? I mean, where do I need to go back to what I'm asking?
I'm good.
Who's asking me?
The teacher's confused when you use that, you plug that into
Okay, so yeah, I took this answer and plugged it in for that. And I took this answer and plugged it in for that. Are we good?
Yeah.
Oh, all right. So at this point then, guys, c is a constant. It's in both terms. Can I get rid of it? Multiply both sides by c, right? So it's gone. What is x over L? Let's come to my drawing. Here's x, here's L. If this angle here is theta, what does this x over L represent?
X over R.
It's the opposite over the hypotenuse, or the sine. Would you agree that this theta and this theta are the same?
Yes.
All right, so this becomes n1 sine theta 1. We'll call that theta 1. Right? And then since that's a negative, I can take it to the other side, can't I?
Yes.
So I say equals n2. And what is d minus x, which is this, over L, equal in terms, excuse me, that's the wrong, okay, this is my angle that I'm looking at, theta 2, theta 2. So if I have this over this, and this is my angle, what does that represent? Is my angle, that's the opposite side, that's the hypotenuse, sine of theta 2. Talk to me. Here's the thing, we're trying to put it in terms of our equation. So this is this is what we call the incoming angle, right? The exit angle on the other side. So we have the incident angle and the refracted angle. And so this and this are the same angles, right?
You
Yeah.
have different angles.
What did I call them there?
Or you just put them different.
Oh, I put them in the wrong place.
They're wrong on here.
They're wrong here. Yeah, they're wrong here. The board's right. Thank you. I stuck with it right last second because I realized I hadn't labeled them and I didn't think very clearly. So, yeah, because they have to be matched for what we were doing. And when we look at this, what is this? That's Snell's law.
Oh.
And that's a lot of work. I know that's a lot of work. But that's a really cool result.
I need a brush and a little chain.
But
Chain roll.
guys, and that's why I kind of gave you more of a write-up on this, because I know some of you are seeing calculus for the first time in a while. There's not any really particularly degenerate, horrific calculus going on here, but there is stuff people have forgotten.
And this is Cal 1 stuff, so it's even longer.
Yeah. But the point is, I know this is for my own pleasure, but when I first figured out you could derive this, I just thought it was really cool. But the thing is, it's also cool that we don't know why. Why does nature choose the shortest path? The path that takes the least time.
So can you explain how that relates to that? Like,
just like a general summary?
How does that relate to the picture? Yeah, so the N1 and the N2 are of course just the two indices of refraction.
Yeah.
By definition, our angle of incidence is the angle that we have with respect to the normal.
Okay.
So what we say is those are alternate interior angles. So this is clearly going to be the opposite over the hypotenuse, which is the sine of that angle.
Okay.
All right, and the same thing here. This is my angle of refraction, but they're opposite interior angles. So the opposite side of this angle is this entire d minus x side, and that's my hypotenuse. So that gives me my sine 2 coming from here.
That is crazy how it does choose the shortest.
So out of all the possible paths it takes the one that takes the least time. Yeah, but I know that I'm easily amused. Now, I don't want to abandon this if you've got any questions. Does anybody need to see any part of that explained better? And I hope everybody got, I marked the angles wrong on there. The angles I've marked are the complementary angle to the angle you actually want. So I actually I developed the law of cosines. No, I mean, the angles I marked are the cosines. But,
It looks worse on the paper.
you know, I told you it would. But here's what I said. This paper will make more sense after you've seen this and you can use it to review from. But looking at it cold was scary. All right. Oh, yes, so that's good. I did go over that. I wasn't up there with you. I just totally missed it. So what questions do you have?
Just remember.
Also be like, that quality of life though.
If you have unpolarized light hitting a polarizing filter, only half ever makes it through. You can get polarized. Whatever it is, cosine squared of the angle.
Your excuse.
You're studying over the weekend? You're studying over the weekend?
Yeah, I'll be studying.
Studying on Sunday at all?
Yeah.
Sunday evening?
Huh?
Sunday evening? When it gets
Sunday
together?
evening, yeah.
Yeah? You're in over there.
5:10.
Did you get to any college?
5:10, 7:59.
Look at McKee. Up here for me.
Get off work at like
We watching. I've worked more than that. I'm watching it.
Right? Is it-
I think so, because the one that I
When
told
you,
them I got in there,
where were you living?
And McKee is supposed to hear for us.
Yeah, Bruce can
You know.
we're not gonna go there anyway.
I know, right? We just want to know.
So if I take a look at the curve, and I'm a player, and I'm here, all right, I would not be able to see the sky. The sky, if I did do something, the light was something like this, and interact with the sky. This is like, it's not produced. So in order for that to be that, something has to happen. Well, it turns out that during that path, the blue light is the most easily scattered. So it's scattered off in this direction. And if any light is on my eye, it's scattering on the sky. And that's why I see the blue in the sky.
They're like water.
Whereas if I look towards the sun, it's always black. Right, so then what happens, if I have the sun down here and it's going through a lot of atmosphere before it hits my eye, the blue light gets scattered out for somebody else to see.
Well, good luck on studying.
But instead, the only light that makes it all the way to my eye through the low sun is the red and the orange.
So you see your face is just not. And what was the
The polarizing filters, right, you know, the law of malice, that I is equal to I naught times cosine squared theta, so you just have to know how to use that to solve simple problems. So, yes. Well, I don't mind answering the questions, but have you done the homework on it? I think it was lucky. Yeah, so I mean, so anything that you did with the polar, I mean, the polarizers on the homework.
I was saying it now before I came to
Then it's
class.
like that. But anyway, you can also ask Monday if after the weekend you're pulling your hair out and it doesn't make sense, I'll be around and you can come ask me on Monday.
Alright, thank you.
Yeah.
I wanted to ask you about, so,
Did that get turned off?
alright, for sure. Yeah, like the Moab that was dropped in Afghanistan recently.
Of course, I'm out here at Moab and I thought,